Hello everyone, welcome to Explore Hop. For this example, we're told that a ladder 10 meters long rests against a vertical wall. The base of the ladder begins to slide outwards at a rate of 0.5 meters per second. And we're asked, how fast is the top of the ladder descending when the base is 6 meters away from the wall? Let's first draw a diagram of what this looks like to help us visualize this problem. So this is the vertical wall, and the ladder will rest against this wall to form a right triangle. And we know that the ladder is 10 meters long. So here's the ladder, and this side length is 10 meters long. And here's the ground. And we'll let x be the distance from the base to the wall. So this distance over here is x, and we'll let y be the height of the top of the ladder from the ground. So we'll label this distance y. Now let's write the givens. Since the base of the ladder is sliding outwards at a rate of 0.5 meters per second, then this means that the derivative of x with respect to time is equal to 0.5. So dx over dt is equal to 0.5. And we want to know how fast the top of the ladder is descending, which is the derivative of y with respect to time. So we want to find the derivative of y with respect to time. So dy over dt when the base is 6 meters away from the wall. Now let's write an equation that relates the two variables x and y. Notice that the ladder forms a right triangle, so we can use Pythagorean theorem. And we get that x squared plus y squared is equal to 100, which is 10 squared. Now, let's isolate for y. So y squared is equal to 100 minus x squared, which means that y is equal to the square root of 100 minus x squared. And we only consider the positive square root, since the length cannot be negative. Now, we want to find the derivative of y with respect to t. And we can do this by applying the power rule and the chain rule. So we get that dy over dt is equal to 1/2 times 100 minus x squared to the power of negative 1/2, which is the power rule, then times the derivative of 100 minus x squared with respect to x, since we're applying the chain rule. So that's negative 2x. Then times the derivative of x with respect to t, dx over dt. And we can see that the 2's divide out. So this is equal to negative x times dx over dt divided by the square root of 100 minus x squared. Now, subbing in the derivative of x with respect to t, dx over dt, which we know is equal to 0.5 meters per second, or 1/2, we get that this is equal to negative x over 2 times the square root of 100 minus x squared. And now to find the derivative of y with respect to t, when x is equal to 6, we just sub x equals 6 into the equation for the derivative of y with respect to t. So this is equal to negative 6 over 2 times the square root of 100 minus 6 squared. And this is equal to negative 3 over the square root of 100 minus 36, which is equal to negative 3 over the square root of 64, which is equal to negative 3 over 8. So this means that the top of the ladder is descending at a rate of 3 over 8 meters per second when the base is 6 meters away. So therefore, the top of the ladder is descending at a rate of 3 over 8 meters per second when the base is 6 meters away. And that's it for this example. Thank you for joining us. See you in the next lesson.